Um, we are moving. Hello, hello. Welcome. Happy December 1st. Crazy December. We only have a couple weeks left in the boot camp here, so I'll have to confirm. Maybe we don't have a live session on the 15th, right? I think it's just this week and next week. We'll
I think
confirm. Yeah. We'll see what there's only a couple weeks left though. And remember after week 10, which is next week, you do have an extra few days to let's see if I can find like a good calendar for December. You have an extra few days to get everything kind of logged in and submitted. So I think, yeah, today's the first. Module 10 starts on the 3rd. Module 10 should end on the 10th. And then I think you have another week or so. You definitely have the weekend of the 13th, 14th to get everything squared away. Friendly reminder that to finish the course, there is a capstone that we're going to be building over week 9 and week 10. And I'll get to some more details on that in a minute. But after you have successfully progressed your way through the capstone notebooks, you're going to be synthesizing all the results together into a write-up, or I think definitely a slide deck. I would recommend turning that slide deck into a write-up, just a sh fairly short white paper as well about your project. But Karen and I are going to be the ones grading your final project. And I know they gave us like a soft deadline of a week to kind of get that all in. So definitely trying it, everything done and submitted the week of the 15th. I'm going to confirm that we don't have a live session on the 15th. We definitely have a live session today, the 1st, and next Monday, the 8th. But Karen and I will be around definitely in the forums and through the platform the week of the 15th as needed to kind of finalize and lock up the grades for the capstone project here. So yeah, only 2 more weeks, which is kind of fun, but also kind of sad. But definitely will be good to get this over before the holidays in the last 2 weeks. If you need extensions for any reason, feel free to reach out to the student success manager at the course. Uh, but again, you probably don't want to do an extension over the last couple of weeks of the holidays and the year. But definitely let us know. We're here to help. So we'll get all of that straightened up. And again, remember, Karen and I are the ones grading your final capstone submission. So please just be respectful of our time as well. And we'll kind of share all the rubrics and all of that stuff going into next week. All right. So speaking of the capstone and this week, it was a holiday weekend in the States. So sorry for kind of the delay on my end. I didn't really get back online until Saturday, Sunday. But I also had some issues with YouTube. So I've done my recording for the week 8 recap and week 9 preview, but YouTube won't let me upload the video for some reason. So I'm gonna get that figured out today. But yeah, quick recap of where things were. Where we ended with the week 8. Week 8 was our intermediate machine learning week. So we did a deep dive into the tree-based algorithm of the or family of algorithms. If you remember, we talked about how there's three different families of algorithms that we use for supervised machine learning. Linear models, which will be your linear regression, logistic regression, etc. Tree-based models, which are going to be based on decision trees, which we can then expand into forests, random forests, which we can then boost and emphasize good trees and boosted forests or XGBoost, light GBM, light gradient boosting algorithms, and cat boost, categorical boosting algorithms. So these are going to be your kind of pinnacle of the tree-based algorithms. And then finally, neural networks, which we've talked about in high level concepts. And I don't think we'll go too in depth in that in this course, but definitely there's other kind of more advanced AI data science courses out there that'll go deeper into neural networks. However, again, in my experience in regular industry, tree-based algorithms are going to be more ubiquitous than neural networks through TensorFlow or PyTorch, especially for traditional structured supervised machine learning problems. So again, supervised, you have regression and classification. Regression, we want to predict a continuous number. Classification, we want to predict a probability of belonging to a class. In week 8, we also touched on um, unsupervised learning with clustering and dimensionality reduction, but we did not go in depth, at least in not during the live session. Let's see. Finally, we also locked down how to evaluate classification models. Specifically, we talked about type 1 and type 2 errors, precision and recall, classification reports, confusion matrices, all of that good stuff. And we did a full end-to-end pipeline where we tried to predict whether it was going to rain in Australia or not. And we used, yeah, imputation for null values, encoding for our categories, scaling for numeric, do our train test split, do our cross-validation, hyperparameter tuning, and finally evaluate and pick the best model. My only note on last week that I want to throw out there is during the live session, my kernel died at the end, but I did go through after the class and get the XGBoost version working. And if you did that on your own time as well, then awesome. And you'll notice that with the XGBoost version, it actually is a better model in terms of recall, which is your true positive rates. So this 55% recall outperformed the logistic regression and the random forest, which again, big idea. How do we kind of talk about boosted trees as kind of one of the most accurate and explainable algorithms without going into neural networks? And yeah, same type of thing with feature importance. The humidity and pressure today is most predictive, most important when trying to predict if it's going to rain tomorrow. All right. That brings us to week nine. Week nine and week 10, as I've mentioned, you're going to be, instead of having discrete media sets with notebooks that are independent of each other, all of the media sets and notebooks throughout the week are going to build off of each other. In a way that like technically you don't have to do them in order. You're going to end up like creating data sets and then re-pulling those data sets from the cloud, etc. But each notebook is going to be part of a larger whole that's going to make up this capstone project. Now, so for the capstone project, let me actually do my introduction for that. Let's see, this will be module 9.1. Our scenario here is that we are a, I guess, competitor for SpaceX, or we are just interested in SpaceX. And what we want to do is we want to predict whether or not a rocket launch from SpaceX will land successfully. So when it returns, right? So the point of SpaceX is that its rockets are reusable after it drops off its payload at the ISS or in orbit. The rocket can return, land, and then be reused again. However, not every launch resulted in a successful landing of the booster or rocket. And so, if we can predict the probability that this rocket will land successfully, we get a better estimate or understanding of, I guess, total cost of the project. Notice that we're not actually going to be predicting cost. That would make it a regression problem, right? Trying to predict the total dollars that this will be. That's a continuous numeric variable. Instead, we're going to be predicting a probability of the stage landing to be reused. So just keep that in mind. We're going to be building a classification model. So in week nine, our goal is to acquire data, clean the data, explore the data, get a really strong understanding of what data we have. We'll do a little bit of feature engineering and pre-processing as well. And then in week 10 is actually going to be the model building. So that's kind of the big idea for the capstone. For week nine, we're going to be going to the official SpaceX API. We're going to be web scraping from the SpaceX Wikipedia page. We're then going to be combining that information into a SQLite database, writing SQL queries to investigate the data, and then doing some basic pre-processing engineering as we try and get the data ready for modeling, which we'll do next week. Let's see. We'll go over some of those notebooks live during the live session today. Let's see. For extra practice, the intermediate machine learning I shared last week, this is basically week 8 in a nutshell. XGBoost, cross-validation, pipelines, encoding, all of that good stuff. Definitely recommend you work through some of these free micro courses on Kaggle as supplements to the boot camp. And then I also shared the machine learning explainability one, which I have not shared before. This kind of goes beyond what we talked about last week with feature importances, but it goes into details of things that are actually used in the real world to investigate model explainability, such as partial plots and Shapley values. We don't have a lot of time to go into that over the next couple of weeks, but do note that I highly recommend trying to get human understandable insights from your model. This is a typically a big problem in productionalizing models in data science in the real world, especially with neural networks, for example. How do we trust and understand how these models are generating their predictions? And that's even worse now with generative AI, right? I was on a webinar this morning through my company and we were talking about actually it was Databricks and OpenAI. So Databricks has a big partnership with OpenAI. Not that this really matters that much. But we were kind of talking about like how the problem with modern like generative AI applications is that nobody's evaluating them. No one understands why or how it's making these predictions, and people are you still in 2025, almost 2026, developing with velocity to create RAG applications, chatbots, LLM summaries, and everything. But we haven't really made sure that everything's explainable and trustworthy and not hallucinating and all that good stuff. So this is a fairly solved problem for typical supervised problems, again, such as regression and classification with tree-based algorithms and even neural networks doing supervised problems. A lot of that is fairly done as well in terms of model explainability. But this is something to keep in mind. Keep that human in the loop, keep that human understanding of your model so it's not a black box. And again, partial plots, Shapley values, feature importance, those are all ways that we can try and understand how the model is thinking behind the scenes. All right. Should be fun. Oh, for the capstone notebooks, it's only 5 notebooks in week 9, but unlike all the notebooks in the first 8 weeks, there are no hints and no solutions. There's no little drop downs or anything that gives you code. There's some starter code that it gives you for the problems that you need to solve, but for a lot of the cells, you are completely on your own. So because of this, it takes a few hours to do it. It took me about 2 hours, 2.5 hours to work my way through all 5 notebooks. So I typically times that by 3 for a student. And I did mine with very little AI help. I did not ask ChatGPT for much. I went tried to go back and reference like old activities and things to make it as usable as possible. So I would multiply 2.5 by 3, which gives you about 6 to 8 hours. So I would estimate it would take 6 to 8 hours to go through all 5 notebooks for week 9 in the capstone. So allocate your time accordingly. I know most of us are spending less than that per week on the content here, but try and do it as much as you can. Try and use ChatGPT if you want to as well to help out. But again, the purpose is to try and synthesize the first 8 weeks into these capstone and notebooks. Um, Cool. I think let's dive into some of the notebooks here. I've done all of them and backed them up. So if you do get stuck on anything, you can reference my notebooks in 9.4 and 9.5. I also don't have time in the live session to go over GitHub, but note that I did pull some additional resources that I've shared before. I think it's this one. Yeah, what is Git and GitHub and some things. So there's some additional GitHub contents in my folder here. And I highly, highly recommend reading over Karen's discussion posts, which are at the top of the Module 9 Lounge, that go over how to kind of upload all of these things into GitHub, what is GitHub, how to use it, all that good stuff. Cool. Last thing to note on the week 9 notebooks, and I'll try and run one of these live. The web scraping notebook has 2 bugs in it. This is in 9.4, where we scrape data from Wikipedia. They're not bugs, they're just a little bit difficult and not that well explained in the notebook. So the first is actually acquiring data from Wikipedia. We need to basically make sure that we're abiding by Wikipedia's robot policy, which I'll pull up here. And basically, long story short, is that if you're scraping Wikipedia and you're not using their API and you're actually using their web scraper, they need to know like who you are and what you're doing. So they're like, just make sure that we need to identify you, right? So this is just for auditability and accountability. We don't want just random people trying to scrape Wikipedia. So to solve
And
this,
I
we need,
suppose, and I
yeah,
suppose if you don't do that, they can ban your IP address.
yeah. So I demoed it here. If you do not include this header that proves that you are who you say you are, you get this unauthorized 403 error. And when you add in a user agent, this is the one that Karen came up with. I'm using it here just for consistency. I don't think it needs to be this detailed, but as it won't hurt, right, for Wikipedia to know that this is an IBM data science course and this is for educational use. You could probably make it shorter if you wanted, but this will work. And once you declare who you are, then the request to get that URL and to get that web page should succeed perfectly fine. We'll go over this when I run the notebook live here too, I think. I wasn't going to run the web scraping one. I was going to run the API one and then the SQL one. We'll see how good we are in time. The second bug on the web scraping one to note is when we are extracting the data from the HTML. And I'll show you what table we're going to be pulling here. If I actually go grab this URL and open it up in my browser, you'll see that we're going to be pulling this table of past historical launches and kind of whether or not the booster was able to land successfully. So we're going to be pulling and scraping this table. And you should see that we want to parse out this customer column right here. And for most of these, the customer has a link to another Wikipedia page, right? NASA and SES, that's and then Tycom, AsiaSat, whatever. However, if you scroll far enough down, some of these customers actually, like this one, SSO, this one doesn't actually have a link on it. So if you check the starter code for how they are extracting this data, the starter code that they gave you basically said, hey, go find the A tag, the link, and extract the string, extract the text. But since not all customers have an A tag, this would throw an error. And so I added an if statement here, which basically says if an A tag exists, then grab the text string from it. Otherwise, grab all the text strings in that column and then grab the first value, which actually works even if there is a link on the page. So technically, you don't even need this first half of the if statement. But just know that there may be a little bit of extra logic here. Again, that's why I like to say that they give you starter code and you have to make it work, right? And there's no hints or solutions to these. But reference my notebooks if you get stuck. I don't think I had problems with any of the other notebooks. It was mostly just those two things on the web scraping to call out. All right. Let's dive into some of the code here for the capstone project. So we're gonna start with. I definitely recommend also participating in the discussion post for this week. This is a good like mental framework for how like we're gonna solve this real world problem. And again, like this is a real world problem with real world data that's very similar to most data science problems that I've ever seen in the world, right? So again, like the main problem, can we predict if we can, if the probability that a SpaceX booster is going to land successfully? That's the overarching business statement. So now we have to try and tie that into our data science frameworks that we've talked about throughout the last 8 weeks, right? So if that's the problem we're trying to solve, what data do you think we need to be able to do that to solve that? And again, you can see the API and the Wikipedia page will help. What are some questions can we ask to make sure we understand the ask, right? How do we decompose the ask of the business question? And then how, given some of these analytical approaches that we've thought about and stuff, like how would we start actually putting pen to paper to actually solve this problem, right? And this, why I really like this discussion post is because every real world data science problem that you work on, either as a hobby or through your organization, it's always going to be just like any project. It's going to be most successful if you put your plan to paper, right? Put your ideas down on how you want to solve the problem and then break that down into decomposable tasks. We can talk a little bit more about data science project management and maybe if I get off topic again. But just like any other problem, right? Just like any other project in the real world, having like an explicit like understanding of what you want to do will just prepare you to actually do the work easier. Right. So everybody for real world problems, they ask all these same things. How do I decompose the ask? What does the business actually want to know? What data do I think I need for this? What features should I probably look for to try and make this prediction? And then what type of models am I going to build? How am I going to know if this model is working? And then how do I make sure that we tie this back from our model creation to the business value? So I liked how Ryan put in some of these thoughts up here. And then I gave a quick little note on how I would get started, right? Like again, don't memorize any of the frameworks. Just think about like the 10,000 foot view, right? Like how does your model relate back to the business question, right? And how would you make sure that you can productionalize it effectively? So just a good kind of way to get started to just put your thoughts out there on how you would actually go about this problem in the real world. All right, so let's jump into content here. I know I'm running pretty hot on time. Cool. So GitHub, definitely recommend reading over this, reading some of the notes in my GitHub, and then reading Karen's notes. You will be creating a GitHub repository. So if you haven't already created an account, you'll need to create an account. You'll need to create a repository that says something like IBM October 2025 capstone. And then from there, you will upload your notebooks and your final submission, which will be your PDF of your slides and a write-up if you decide to go that route as well. And again, we'll more formally declare like what you need and stuff in week 10 when we get there. But again, Karen's notes on how to download the notebooks from the class materials and then how to upload them, even if it's just a file upload in a GitHub, is a good resource. Wow, 20 minutes burnt on just
And
all of
now,
that.
and I'll just plug in again that for people to write some kind of README is
Or
really
I have ChatGPT right on my readmes now. I don't even
there you
bother with that.
go. There you go. Well, I mean,
Yeah.
if you're going to do a write-up kind of thing, they can kind of make a summary of that as for the README.
So README is just a like a file. I don't. Oh, I didn't create one for this.
Oh, I said
But a
readme.md. It's right there.
Yeah, no, I didn't actually
Oh, you
flesh it
didn't do
out.
anything. Yeah, you
It
didn't do
just
anything.
says
Yeah.
IBM Data Science Lab. But yeah, you want to flesh this out with a description of the purpose of the project and kind of some of the findings and things that you found. But yeah, your goal is to hopefully make it doesn't have to be as organized as mine and stuff, and you only need to contain the notebooks that you execute. You'll see that the notebooks will actually create CSV files as well as the database. You don't technically need to download those, but you can if you want for completeness. I actually ran all of these notebooks locally on my computer outside of the lab environment, which is why I was able to generate those data files as well. All right. We have an hour to run. I want to maybe a little bit less to run through some of the labs here. So let's get into the first one, which is going to be the API. I really like the API lab because again, it's a representative of a real world like data set, right? So let's go take a look at what we want to do here. We want to gather data about past historical SpaceX launches to try and then use that as training data for our model. So there's a couple different sources for SpaceX historical launches. I think they do the web scraping one just to kind of redo some of the web scraping work we did in like week 3 or week 4. But I actually really like the official SpaceX API. I've done it in past boot camps and for some hobby work as well. But the official SpaceX API is a very robust, and you can kind of see I'll share this in the notes. But this is the official like documentation, and it's the open source REST API to get data, and the data will be in JSON, and you can kind of see a lot of this information about the launch and things, which is kind of fun. You even get things like the YouTube webcast link, which is very cool. And like this is all real. Like there's this the 4 or 5 hour launch from 5 years ago that SpaceX did, which is very cool. I actually like looking at the Roadster. Yeah, I'm just nerding out. Let's see if this is the right URL. Oh my God. Roadster. Basically, SpaceX like launched a car with that's like playing David Bowie in the background. If I can find it. I'm not gonna get too sidetracked. Roadster, there it is. What's the GET request for it? Oh, V4, not V5. There we go. Yeah, the Elon's Tesla. I don't really care that much about that, but I like oh, it's the heavy Tesla. That was like a live stream that it was doing. I don't know where the live stream is, but if you look at some of these images, you can see that it's like the little spaceman flying around Earth in a Tesla. And this is like real. It's kind of wild that this is just still floating around in orbit.
And the
Very
sign
nice.
the sign in front of him says "Don't panic."
Yeah, yeah, it's the don't, yeah, yeah. A mannequin, and then yeah, it's kind of funny. Anyway, I remember when they launched this in 2018. I was like, what are we doing? Launching a Tesla into space. But yeah, there used to be a live stream available that was like a camera on the front of the car. I don't know if it's still up, but
Oh
anyway,
yeah, we're dead by
yeah.
now.
Yeah, long story is the official API is just like any other official API from any other real world data set. It's representative. It's the same type of URLs, same type of response, same type of versioning, same type of documentation. So again, even if you go off and do a finance problem, you'll likely be pulling data from an API with similar structure to the SpaceX API.
Probably
Um,
The Roadster thing was probably what got me starting paying attention to SpaceX, though.
yeah. Yeah, and you'll see that once you have completed each of these notebooks, they want you to upload it, right, to your own personal repository, kind of like I have done. And you can see how I do it for the live sessions. I like download the notebooks that we run in the live session, and then I'll actually I'll try and show that on recording here for those folks that watch the live sessions, so they're not totally caught off guard by the GitHub thing. Karen, you're gonna hate it, but I'm gonna show just the file upload just as a quick solution. Anyway, let's start taking a look at the API lab. And again, luckily I've already run most of these, so hopefully we can be fairly quick here. All right, so we're gonna make sure we have all of our libraries installed, and then we're going to just load in those libraries. And then we'll take a look at the API calls that we're going to make. So you'll see, like I mentioned, most of the time it gives you starter code that's actually pretty robust. The notebooks will indicate to you what do you need, which cells need edits. But you'll see here that we want to get information about the rocket. We can do that by making a request to this API v4 rockets, which again, if we check the official documentation, you can actually see it on here, right? Here's how you make a request for one rocket. You need the rocket ID, and then you make that URL request, make the URL, and then make the request. And this is the data that you're going to get back from it. And you can even double check that this is a real image. And yep, there's the SpaceX rocket, which is pretty cool. So again, going to the notebook here, they're pulling the rocket ID from some previous response and then making a request for it. This is all pre-cookie cutter, pre-given to you. So same thing, we want to extract the latitude, longitude, and name of the launch pads. And we're going to be extracting all this information from the JSON of the response. And then same thing with the payload. For the payload, they're only grabbing things like how heavy is the payload and which orbit is it in. But know that there's more information brought back in these responses. Same thing with grabbing the core. Again, we're going to make a request to the core endpoint, extract information that we want from it, and then append all of that to our information. And if I actually go to this URL, this is a pretty cool URL. This is again a real API endpoint, and it'll list every single launch that SpaceX has ever done, which is 187 items here, which isn't that many, but it'll be enough. And as we'll see, there's a lot of good information here to build a model off of. All right, so let's make our request. And then also like to do some things like check the status code, which should be 200 if it was a successful request. So this was a successful request, and we can check the content, which is going to print a lot of outputs here. It's printing all 187. So again, typically what I like to do is just limit the output. All we're trying to do is verify that the request worked. So we can just limit oh my God. We can just limit this output to the first 500 characters. And we can see, yep, it worked. Cool. And here's the webcast of this first launch. And yeah, this is from 13 years ago. First launch of Falcon 1. Wow. Do you think we actually get the whole video here? Oh, look at that. It's taken off. Oh no. Oh no. Oh no. It's on fire. And then I think it like falls back into the ocean. Womp womp. So yeah, it did not work, but that's cool. So again, all we're just validating is that we made a real request and we got real data back. We have a backup URL. We have a backup JSON object here that I think it only contains, we'll see how many it actually contains. But if I, we'll actually look at it. So the first question here, use JSON normalized to make a request to this URL, which is just a cached backup in case the API is down for any reason. And we can use the JSON normalized function um, to actually do. I'm just going to pull this from my own code just so I don't get too bogged down in time. Boop, boop, boop. Oh, actually, I pulled it from the real data set. Good job, me. So if we pull it from we know what the content looks like from our response here. In this case, all that I'm doing is I'm grabbing the JSON from that response and then making this data frame called data using that JSON normalized function. And if we look at the head of the data frame, we should see that we have all of this data that was provided. Know that JSON normalized does its best to flatten out the JSON, but it doesn't always work. And you can see that for cores, for example, because a launch can have multiple cores, they just return this as a list within the cores column, which isn't very good for model building. Remember, we want a flat normalized rows and column data frame. So luckily, I think we're gonna end up dropping a lot of those rows. Note that if you really wanted to do this against the static JSON, you can do that as well. Response to equals requests.get against the static JSON URL. And then we can grab the JSON and then we can make a new data frame if we wanted. And I think the only thing I want to call out is that this only contains 107 launches when if we use the live one, oh my God, this is going to be like 187. Yeah. Oh no, it's still a hundred. Oh my God. Print data dot shape. Yeah, so there's been 80 launches since we last cached off the response. So try and use the more up-to-date one if you can. All right, then it gave us some more cookie cutter code. Again, you can read over this if you want. Essentially, all that we're doing is dropping the columns that are not useful or are not flat. As I mentioned, cores, for example, is a list. So what they're doing here is they're just grabbing kind of just one core so they can try and flatten it out. So we can run this. Again, this is some data cleaning of our JSON object. And then what we're going to do is clean it up even more. Again, there's multiple ways to clean this data. This is just one way. Again, the goal here is to create a flat, clean data frame. And all that it's doing is running functions to go extract all this other additional data about the launch and add that information to lists. So for example, the boosters, we define this function up here at the top. For each launch, for each rocket, we're going to get information about that rocket booster, right? So again, it says we're getting supplemental information that wasn't included in the original API request. And then finally, this is the important one. We want to create our flat relational two-dimensional data frame. Again, two-dimensional data frame, rows and columns, and no nested substructures. I only want one value per cell. And we can go off on your own and you can look at that different kind of normalization pattern. Now let's create our data frame. I think I just called this one df. Yep. And all we have to do is wrap this dictionary around our data frame function, and then we can take a look at it. And if all goes well, we should still have about, we're down to 94 here, which is good. So we have 94 rows that contain all the information of our thing. But what I wanted to point out is that if I look at this data, it's flat, right? It's two-dimensional rows and columns, and I don't see any nested substructures anymore. From here, we only want to filter to the Falcon 1 launch. So that's a pretty simple. All we're going to do here is filter to where our booster value version is not Falcon 1. I probably would have done equals Falcon 9. I don't know why that it gave you that as a hint, but whatever. And then let's double check that it worked. I'm gonna do a data falcon dot head here. And all we should see is that we've updated this flight number column to be the first flight of a Falcon 9, etc. I'm also gonna print the data falcon. Oh my God, data. I hate the autocomplete in this UI. Falcon 9 dot shape. Again, dot shape just returns the rows and columns of the data frame. So it looked like we only had 4 Falcon 1s. We're down to 90 rows, but everything should look pretty good here. Some more data cleaning, and now that we have our normalized flat data frame, we need to do some basic like imputations, and I think this should all line up. 5 and 26, is that what I got over here? 5, okay, perfect. We have the same number of rows and everything. We can see we have some null values in payload mass as well as in landing pad. And we can even do a data falcon 9 dot info if we wanted a more robust summary here. And again, we can see we have 5 null payloads and 26 null landing pads. And note that the null values for landing pads is actually expected because some booster rockets just landed on the ocean or in the ground. So these represent null when landing pads were not used, which is expected. So now we're going to deal with our missing values. This is known as imputation. So maybe I'll put that in here. Remember, imputation is one of our steps in pre-processing. we want to make sure that when we train a model, it's not trained on missing values. And sometimes what I do personally is you can have an imputer in a scikit-learn pipeline, which I think I demoed in week 7. But definitely would recommend like looking at this, right? So there's different ways of doing imputation, and then you can even have that simple imputer as part of a larger pipeline, which is kind of fun. I'll keep that link open as a documentation to check later. Yeah, here you go. So this is like an example scikit-learn pipeline. We can have an imputer for both our numeric and categorical features. Notice in our case here, we're doing the imputation outside of our machine learning pipeline, which is fine. You can think of this as like data engineering, where we want to have a table that's ready for business analytics and reporting. In which case, if I create a table that's going to be powering a report downstream, I also want to make sure that it's clean, flat, and not having any null values in it. So what we're going to do here is we're going to grab the average and the we're going to impute the 5 missing values with just the average of the column. Equals data Falcon 9. God, what a terrible data frame name. Dot payload mass dot mean. And then we should be able to replace the value just with a simple fill NA. So we're gonna fill NA, fill null values of payload mass with the average payload value that we determined. And we can double check that this worked. If I check what this looked like on my .info, we should see 0 missing values. Hooray, go us. And then we can save this off if we wanted to a CSV. And we should end up, oh, it doesn't appear here. Womp womp. I thought it would. No worries if it doesn't appear there. Cool. Oh, there it is. Hallelujah. So then we can save this notebook. And like we mentioned, once you finish the notebook, we can download it using kind of the right click download. You can also do that for the CSV. I think I'm also going to do the web scraping notebook just because these two notebooks are the hardest and longest notebooks to deal with in the week 9. The visualizations and SQL queries are pretty straightforward. So I'm going to do this web scraping one. This is more for Karen's benefit. And then I'm going to do the SQL one, and that should take us to 2:30 Central. And George, if you have to hop off early, no worries at all. All right, so let's dive into the next notebook. So technically, that API data frame and CSV, this is good enough, but we wanted to talk about how, again, in the real world, you typically have multiple data vendors. If you bring this back to week 3, week 4, we talked about APIs, we've talked about FTP servers, we've talked about just public external databases, and we also talked web scraping. So we have a second notebook here to acquire a secondary data source from Wikipedia. Note that technically it's all pretty duplicative of what's in the API, but for the sake of the capstone example, this represents a second data vendor, so a completely new raw data set that we also have to ingest that's different from an API. So our data ingestion is going to be slightly different than the API. Instead of requesting JSON and then flattening JSON, in this case, we're going to be requesting HTML or other markup language like XML or something, and then using those tags to parse out information. But again, the goal is the same. Note that whatever data set you're bringing in from whatever data vendor, your goal is to have a data frame, a pandas data frame that's flat and normalized, rows and columns, one value per cell. So in this example, again, that's representative of a secondary data source and data vendor. We want to scrape this table from the SpaceX Wikipedia, which we've already kind of shown in the class. Notice that we're pulling the past launches here. And for those of you paying attention, you may have also noted that we're pulling a cached version of the web page, just to make sure that we all end up with the same results here as we kind of move forward. So note that the only thing slightly differently this time is that we're going to use Beautiful Soup to do our markup language parsing. Remember, we're doing HTML because that's the tag structure of the web pages, but it has been known, and I have done it in my own work, that a data vendor will supply XML, which again we showed back in week 3, is what that looks like. So luckily, XML and HTML are both structured pretty similarly in terms of extracting data. We just have to use a tag parser to extract the information out of tags. So again, HTML web pages, XML are just old school data vendors usually, but either way, we need to learn how to extract information from both of those different documents. And I bundle them all up as one: JSON and then markup languages and then databases or whatever else you want. All right, again, we have some helper functions here that are given to us, which basically is looping through all these different markup cells. We want to extract and normalize and just clean up the text. As you'll see with HTML and even with XML, the text content can have a bunch of foreign characters that websites need to be able to render them correctly. But for our data science needs, we don't really need. They're not really necessary. So you're going to see that we're going to be stripping out things like the unit text and making sure that things are numbers and like removing new lines. There was one that I did there was another change that I made in this cell. Let me see if I can find it real quick. I forgot that I wanted to clean something else up here. Ba, 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 ba. Where are you? I guess we'll find it when we in the notebook. There was one thing that I added for like a dot strip. I think it was the booster. We'll see if we can find it. We'll do it live. Um, cool. So again, here is my web page that we're going to be scraping from Wikipedia. We need to go grab the HTML from it. And again, this is going to be the example that we walked through at the beginning of the lecture, which is if we just go get the data like we normally did back in week 3, request.get and look at the status code, you'll see that we violate their robot policy. So to correctly extract the HTML, we need to supply that user agent as a header. And then I recommend limiting your response just so we don't print an excessive number of characters. So this worked, and we were able to bring back the HTML successfully. Next, we're going to create a new beautiful soup object on that. I think it's this response.text. Why am I doubting myself? Oh, let's see if that worked. And then soup.title. Oh my God, list of Falcon 9 and Falcon 9 heavy launches. Look at me not not looking at my past self. Cool. If we keep going here, next stuff is that we want to extract all of our tables. HTML tables equals soup dot find all, and I want to find all table elements on the page. And then we can print the length of HTML tables. And we'll see that if all goes well, we found 25 tables. So we're going to grab the third table because that's the one that we care about. And if we grab that third table, we can see that it contains all this information. This seems like a lot of text, but I guess we'll leave it. But again, all I'm referencing here is that I'm double checking that this is the right table that we want. So we have column names for flight number, date and time, the version and boosters. And if I scroll down, I think that's what we want. Flight number, date and time, version, boosters, all that good stuff. Cool. So that seems to be working correctly. I think this may only be pulling the 2010 to 2013 launches, but whatever. Next up, what we need to do, where is my, so, iterate through all the columns, the T table header, that's what TH stands for, and then run this extract column from header function on it, and then append that to column names. Here's one I did earlier. Oh, there we go. I did shorten it to not blow up my print output. So all I'm doing here is printing the first 500 characters again. And here's our nice little loop that I made. Basically, all we're going to do we're going to find all table headers in our table. For each table header, we're going to extract the column name using our helper function. If the name is not null and the length is greater than 0, we're going to append it to our list. And here are the column names that we got: flight number, date and time, launch, payload, mass, orbit, customer, and launch outcome. 1, 2, 3, 4, 5, 6, 7, 8. And if I check the table, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we missed something somewhere. Version booster, launch site. Oh, we're missing the version booster and all the other ones. I think that's probably fine. Added some new columns. Nice. So let's see how it wants us to do this. Again, it gave us all of this code. Basically, what it wants us to do here is we're going to loop through this specific all of our tables, and we're going to start extracting information here. So you'll see for the first one, we want to append the flight number into our list. Essentially, kind of like what we did in the API notebook, where we ended up with where were we? A whole bunch of lists that we then added data into to then make our dictionary for our data frame. We're going to do that similar logic. We have a whole bunch of lists. Yeah, we have a whole bunch of lists here, and we want to go through and add in all the information from, I guess, all the tables. So let's go ahead and do that. Yeah, I'm not sure why it did this. Basically, what we're doing is it looks like we used the first table to get the column names. And now we're going to find all the tables and then get all the data from all the tables. Because again, if you look at the page, it's split into different sections. This is one table right here, but then 2014, this is a second table. And then this is a third table, right? So we technically need to loop through all of these tables. And that's what this cell wants us to do. And again, it did most of it for us. We just need to fill in the blanks here. Append the flight number into the launch dictionary with the key of flight number. We can kind of see what we're supposed to do for that. It's basically just find our flight number table, flight number list, and we're going to append the flight number, which is extracted up here. And you can see that we're using this key right here, launch dictionary flight number. So I'll actually type the next one out. We want to append the date into the launch dict with the key of date. So we can see here that we have this list right here, launch dict date. I'm going to copy that. And then down here, I'm going to do my launch dict date, just like we did up here, dot append. And I'm going to append this date value that we just calculated. So same thing, we're going to be doing time next. So let's slap this in here. Launch dict time dot append. I'm going to append this time variable that they parsed out here. Booster version, this is fine as well. We can leave this starter code as is, but it's the same idea. We're going to be grabbing this version booster list, and we're going to be dot appending this BV value. And just for the record, I am going to go over the GitHub thing here in a minute as well, just for the recording. Dot append BV. Let's keep going. Launch site is up here. Note that there's a small typo in the notebook. Launch site here is lowercase, but in the comments, it gave it as a capital uppercase. So this does need to be lowercase. So I recommend just fixing that to make sure you're not confused. Dot append the launch site. Payload, same dealio. And we're going to be appending this payload variable. I'm cheating a little bit. I'm not scrolling all the way up anymore. The key should be payload mass. Notice this one is also lowercase, but the comment got it correct. Payload mass. Only a few more. Orbit is next. Again, it does all the hard work of actually extracting the variable for us. And then the key is orbit. This is where we'll come back to with customer. So customer, let's do the same thing. Notice how it's extracting customer by grabbing the text from the link and then launch outcome. It gave us that as well. Again, notice the lowercase. This is actually correct. And then this last one, we're going to do our booster landing. So same deal. That's our variable. I'm going to be appending it into our column called booster landing. So this looks great, but now if I run it, note that it's going to throw an error. So here's our first error. None type object has no attribute string inside of our customer. And this is the error that I told you you'll run into. Let me make sure. I feel like I should be commenting out another print somewhere. Oh, print BV. Let's comment that one out. Yep. So there's our error. Our customer is not correct. So like I mentioned, this is because not every customer has a tag. So if row 6 dot a dot string, then I forgot how to type. Is it a colon? I forgot how to code. Why am I blanking? It is a colon. Okay, I'm not. This is the UI that's making me doubt everything. Then customer is going to equal that row 6a dot string. Else, if the a tag doesn't exist, then what I'm just going to do is I'm going to grab customer row 6 dot string, which should pull all of the strings. And then I'm going to only grab the first one. But I'm going to wrap it as a list just to make sure that this is the correct type. Grab the first string and then add a dot strip here. So that's just to clean it up. And that should work. Um, oh, if row 6 dot A. There we go. So that worked. Magic. Oh my God. Let me double check I did that right. Yeah, if row 6 dot A. Perfect. And then we should be able to make a beautiful data frame off of this work. We can print our df.shape and look at our df.head. And oh my gosh, that's what I wanted to change. You'll notice that launch outcome has these backslash new lines in it, which is to me obnoxious and annoying. So if you scroll all the way back up to our helper function, we should be able to do something for landing stress status. Uh, is it landing? I already forgot. Is it landing? Launch outcome. How do we grab the launch outcome? I'm just gonna check our function here. The launch outcome. Launch outcome. Where are you? Launch outcome. Okay. I think all we need to do here is add a dot strip to this one. Is that what I did? Launch outcome. No. Row 7. Where did I go do that dot strip?
Just above launch outcome, I see it.
Think it was. I swear I edited one of these ones up here.
Just over here. Table.
7 dot strings. It's all right. Those are because I cleaned it up. So if you look at my table, oh no, I did still have the dash ends. I didn't clean it up. I guess I was too. If I add the dot strip here, it like doesn't work for some reason. I think I was too lazy to figure it out. Yeah, so it still didn't work. But there's a way to strip out that slash n, but I'll leave it as an exercise for the reader. Cool. So we have our beautiful little data frame, 681 columns, or 681 rows, which is more than we got from the API. Because I think it's unique per payload. So I think you could have like the same launch, could have multiple payloads or something. But either way, that's kind of this notebook. Sorry, we went through a bit fast there. I still want to go over uh the sequel one. And we only have about 25 minutes. All right, so that worked. We got both these notebooks in. Again, I did both of these notebooks just now in about an hour, and if you go slower through it, it'll take you at least a couple of hours. And these notebooks are the most difficult ones of week 9. So just again, go slow through them, work your way through. Keep in mind the big idea that what we want to represent here is data, your ETL pipeline, data extraction and data transformation from different data vendors. We have an API vendor, we have a web scraping vendor, and we want to grab the data, clean it all up, and have them ready to go. For completeness here, I guess we'll come back. I'll come back to this for the GitHub exercise. All right, there's a few more notebooks that you need to do in 9.4 and 9.5. One of the next ones in 9.4 is doing some data wrangling. If see it here at the end. Great. Blah, 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 blah. And then I'll just hit yes to all these
I'll just
questions.
just go over to the right-hand corner to the little arrow thing and
No, because it's
the
within the
rest.
9.4 media set.
No, no, no. Go over to the right side.
And
There's a little less than thingy up to the right, just below your right there. Click on that and just click the one
and
you
go
want to
down to
jump to.
the
Yeah,
nice. Do it.
saves you the trouble.
Smart. Great. So in our data wrangling example here, again, I'm not going to do this notebook, but basically what it wants us to do is given some of our data, let's do some exploratory analysis on it. So they call it data wrangling, but I think it's more of EDA part one. We want to calculate some leaderboards, look at some numbers, make sure that we actually have a decent amount of data. And what I also like to call like this first stage of EDA is more so just a foundation setting for you. As a data scientist, you need to be an expert in your data sets before you build models off of it, even if you're not necessarily a domain expert in the space. So, sure, you may not work in aerospace engineering, you may not work for NASA, but you need to still understand your data if you're going to build a model off of it. So that's what this activity is all about. Start exploring the data and start making sure you have an understanding of what the data looks like. So this is a quick example. My last notebook here on 9.4 is the data wrangling notebook. I'm not going to do this one live, but I wanted to show a quick example of what you're going to be doing. It's a pretty quick activity. Basically, read in your clean data that you've already done. And again, this is a cached one from the API that we saved off as dataset part one. And your goal here is to do some value counts, make sure you understand the orbit and abbreviations. Again, like making you an expert in this data set, right? So we give you some information about what all these orbit abbreviations mean. You do some more value counts, look at some more leaderboards. Again, I also think this is sanity checking. Does it make sense that most of these launches are going to be in GTO, geostationary transfer orbit, and ISS going to the International Space Station? And I'm like, yeah, that kind of makes sense, right? That most of SpaceX's launches are going to be moving satellites around and bringing things to the International Space Station. I was like, yeah, all right, that makes sense. I'm looking at some of the other ones here, looking at the different types of outcomes that we get, whether or not, how do we define whether or not a landing was successful, what that looks like, what's the value counts. And again, we can see that we're a little bit imbalanced. Of the 90 records in this data set, 60 of them had successful landings, 30 of them failed their landing. So now we're starting to build towards what our model's going to look like. All right, the next notebook that I'm going to review, I guess not in its full entirety, is the SQL notebook. In 9.5, we have two more notebooks that you're going to work through. The first is a SQL notebook where we're going to take our data sets that we extracted and transformed. Again, in this case, it's just whatever our full SpaceX data is. We're then going to write that data to a database and then we're going to execute SQL queries to explore and interact with that data. Again, this is a very similar workflow in the real world. Extract data from your vendors, shove it into a database, and now your downstream analysts can query that data as well. Note, just for completeness, the second notebook you're going to be doing is a similar EDA, exploratory analysis, but you're going to be creating visualizations. So you're going to be using Seaborn and Matplotlib to create different types of scatter plots. We're trying to investigate relationships between our variables and features, as those relationships will help dictate and drive model performance in week 10. Again, I'm not going to go over all of these as well. They're all pretty repetitive. Basically, do some minor wrangling and then throw together a Seaborn or Matplotlib plot. You're going to generate some bar charts, some scatter plots, and then your goal is to hopefully observe some of these relationships that you're going to be building on here. And you'll actually see, I thought this was interesting. Over the decade of data in the data set, that SpaceX got better, right? Like, which makes sense that the later you go, the more likely it is that they're going to have a successful landing. And then we started looking at what columns do we want to use to train a model? What would it look like to encode those features? And how do we make sure that we have our correct data types? Again, to train a model, we need to have all numeric data. We need to have our numeric data imputed. We need to have our categorical data encoded. And if I was them, I would have added a scalar to payload mass. But I think we're going to redo all this in a pipeline in week 10 anyway. But yeah, this is kind of your visualization notebook of the EDA. So in total, you're going to have about three EDA notebooks. The first one in 9.4 gives you a foundation to make you an expert in the data set. The second one does a SQL investigation to practice your SQL skills. And the third one is a visualization exploration to help you visualize relationships between these features and determine which features will be most predictive in the final model building. All right, so going back to our activity here, I'm gonna do I'm gonna give some examples of the SQL one and highlight some of uh, the more difficult SQL queries. This is great. I don't know why I hadn't really clicked in that before. So I'm going to open up the first notebook here. This is the EDA with SQL. We'll spend about maybe 7 or 8 minutes on this, and then we'll end by walking through how to upload all of these into GitHub. All right, so let's go ahead and get this kernel up and running. Yeah, I was gonna say they probably shouldn't have installed SQL Alchemy 1.4, but whatever. Hopefully this works. We're going to initialize our database as a SQLite database. And then we're going to go fetch our data from our previous 9.4 activities that have all been cleaned up. And we're going to save that data to a database called a table called SpaceX Tibble. And then we're going to create a secondary table, which is going to be that exact same data set, but where the date is not null. And the SpaceX table is the one that we're going to utilize in our queries. So we'll start with some warm-ups. We want to look at the names of each unique launch site. To do a multi-line SQL query in a notebook, The syntax is percent SQL, and now we can write our multi-line statement. So the first statement that I want to ask is like, what does my table even look like? Because I have no idea what this data looks like. So select star from, and my table is space X table. And then we'll add a limit 5 to only bring back 5 rows. And if I execute that, it doesn't like it. Key error default. What am I gonna do wrong here? Is it triple? Nope, that's correct. I think it's the SQL Alchemy version, if I had to guess. I wonder if it's the SQL Alchemy version. So let's do. I'm just gonna get rid of that 1.4. How do I force it to upgrade? I don't even know what the most recent update is. So I'm just updating SQL Alchemy to whatever it is. I was already imported, so hopefully, I was gonna say you shouldn't need to reload. And then let's see if that works any better. Great. Let me,
You
that looks a
created a
little bit better.
table, so you created a table, go back to the select.
Yeah, yeah, yeah. I'm gonna drop it though,
Okay.
and then recreate it. Great. And then let's see if this select
I
works
know
now.
I had that and I fixed it and I don't remember.
This key error default.
I'm trying to remember. I forget now what it was.
Table. I guess we're gonna just add in this config.
That was it. I remember. That
Was
was,
it?
yeah, I think that was
Okay.
it. I know I fixed it and then I forgot what it was. I did the same thing
Uh,
you're doing now.
key error pilling columns. Womp womp. Um, no, it says key error. See if it comes back. Well, that's supposed to be. Maybe we need to update pretty tables.
Let me look and see. Wait, that should be so in here. Hold on one sec. This. I'll have it in here. I'll have it here right now. Come on.
Like me ready to reload the extension.
It's a config. Oh, I've got it. Oh, here. I'll put it on the chat. The line for that. It's you. It's
Thank
not.
you.
I have it now. Oh, one sec. Chat. This is the line you want.
Deprecated default. Disgusting.
Yeah.
Oh, wow. Great job, Karen, coming in clutch. Great work. So you probably don't need to install pretty tables, but you can if you want. And same thing with the SQL Alchemy version. It looks like this is the only line that you really need, this deprecated default, which I guess we did do in a past class. All right, so here's what the query kind of looks like with what we bring back of what the data looks like. And the first thing that we want to do is display the names of the unique launch sites. So we only have a couple minutes to do this. So I'm actually just going to pull some of these from my GitHub. I use a select distinct here. Select distinct launch site from space table, order by launch site ascending. So we only have 4 distinct launch sites. Display 5 records where launch sites begin with the string KSC. We're going to use the like function for that. So again, we can just run this as well. Don't forget your percent SQL at the top. And there we go. I'm gonna skip 3. We'll go into 4. 4 here. We're going to be using the average of the payload, right, from SpaceX, where booster version is F9V1.1, and the average payload should be about 3,000 kilograms. And then the next couple are kind of interesting. Let's see. List the date where the successful landing in drone ship was achieved. The value that you're looking here is this is the outcome that we want, success drone ship. I wasn't sure why it wanted the min function. So your two options here, for me, I just ran this query where I wanted landing outcome to contain the word success or start with the word success and contain the words drone ship, which comes back with this. And I guess if you only wanted the first date, you could do a minimum on date to bring back this 2016 4/8. Task 8 is pretty fun. This one uses a subquery. What we want to do here is, um, oh yeah, this one was numbers. We'll do 7 first. 7 is kind of funky. Basically, what it wants you to do is list the total number of success and failures. So here I'm doing a group by on mission outcome. But if you do this, you'll notice that technically this is all that it wants. You could just bring back these 4 rows. But technically, we have 3 different successes. Payload status unclear and success with a white space somewhere around it. So we actually want to I would recommend combining those values. And this is where I had ChatGPT help me again. So I was too lazy to do it. Basically, I got a case statement where I'm using substrings again to figure out if value contains the word success, otherwise failure. So if you do this crazy query that uses a couple of case statements that I probably shouldn't need to use, this cleans it up. So we should have 100 successes and 1 failure. Last one that I want to show. I'm gonna skip 8, I guess. 8, you're gonna be doing a subquery. So that just means you're gonna have a second query in there. So select payload mass where payload mass equals and then our subquery. And you should get all of these values for the max payload of 15,000 kilograms. All right, number 9 is kind of obnoxious as well. Basically, date values don't exist as a date data type in SQLite. So let me show you kind of what this would look like if you didn't do it this obnoxious way. For the most part, it's a pretty straightforward query. Um, But if I do this, which is basically select the year, select the month, the landing outcome, booster version space site, where we're in 17, and we have a success ground pad, right? Success ground pad. It looks like this, which is kind of annoying that like our month name is 020506. So if you wanted to be over the top and hardcore about it, again, you can add in a giant case statement to basically map each of those month numbers to the month name. And that's what it's trying to tell you up here. Month name doesn't really exist because it's not a date. We're basically just parsing strings, which is not like the best way to do it. Again, this is a limitation in SQLite. Cool. All right, I'll let you do number 10 on your own as well. Number 10 is not too bad. Again, you just need to group by landing outcome and filter on dates. Know that behind the scenes, this date filter is just a string filter. It's sorting it alphabetically by these date numbers because dates don't exist in SQLite. All right, 5 minutes here. Sorry we don't have too much time for Q&A. George, if you have any questions, you can throw them in the chat or ask in the forums afterwards. Quickly, I wanted to go over what you're expected to do on the GitHub side of things. So hopefully you all have created a GitHub account. You may not have as many commits and repos as I have. But your goal here is to create a repository. You're going to go into repos, new. I would call this something like IBM Data Science October 2025 capstone. And I'll provide this link as well so you can see what it looks like. Capstone project for IBM Oct 2025 example. Make it a public repo, add a README, and then I would add a git ignore for Python. And I'll take a screenshot of this. I'll do a license as well. I usually do like a public open source license. Let me take a, I'm just gonna grab a screenshot of this so I can paste it into our forum. Cool. And I'll leave that for later. Let's create the repository. And this will basically create a cloud location on GitHub that you can track and change edits to. So what I like to do here, you can then follow Karen's examples to actually clone the repo and do uh, commits and things to it. But I like to just drag, you can also just drag and drop new files and folders. So here's what I would do. Back into your skill labs, hopefully go ahead and download all of the
This
uh,
is what I said to
oh,
do.
this is what you said? Okay, perfect.
Yeah,
Go
then
ahead
I
and
gave
download.
additional how I could learn about how to do it properly.
Got it. Yeah, go ahead and download all the things here. So I'm downloading these ones from 9.4. Notice you'll have another notebook in 9.4 once you finish it. And then I'm going to download these from 9.5. And again, you'll have more content here as well. Once you've downloaded all of these things, I recommend, I'm just going to copy these. I'm going to go in a I don't know. I'm making a new location on my laptop where I'm gonna call this like I guess 9.4 and I'm gonna create an just I guess example. I'm not gonna actually upload that. But with I'm creating I'm trying to organize on my computer how I want these documents organized. So I'm gonna grab all the 9.4 ones, which should be the API. And I thought am I missing one? Oh, SpaceX web scraped. So I'm gonna steal these and shove them into my 9.4 folder. And then I'm also gonna create another folder for 9.5. And then same dealio, I'm gonna go ahead and grab those documents that we downloaded. Cool. So now if I go back to my GitHub, where are you? I should be able to upload things into my GitHub. So I'm going to highlight both of these folders, and if all goes well, I should be able to plop them up there. And you'll see what it's doing. It's going to hopefully create those folders 9.4 and 9.5, and then upload those notebooks and files. Upload module 9 content for Capstone. And if all goes well, you need to add a message. Adding a message is required, and then you can hit commit changes. I'm actually, let's just hopefully see if that works. Yay. So now we
That's
have our
good.
folders up here, and now you can see the
Even
content.
better than what I did. Even better than what I did. Offer.
Perfect. Yeah, that's how I've taught it before for people for life hacks. So again, the really what I would recommend is organize, and this works for Mac or Windows. Organize how you want your files to appear in GitHub in subfolders and things first, right? Then you're going to do this add file, upload files on your repo, and then just drag and drop the folders up into GitHub. So what we're going to expect is you're going to have multiple folders here for like 9.4, 9.5, and then whatever kind of folders you want for module 10. I think there's maybe two or three other ones for module 10 as well. And then you'll also manually upload your write-up and your slide deck. And then when you grade it, you're going to just share this link with Karen and I in the IBM environment. And then we'll be able to slap a grade on it and call it a bootcamp.
Yeah,
3:31 Eastern.
I thought about going into the actual details of actually cloning and pushing and committing and every, but then I realized not only do they have to install Git, then they have to go through all this stuff to
Yeah.
get. They need to go through nowadays. You have to set up an SSH key and everything. It seems too much for
That's why I
this
was like,
purpose.
yeah, if you're curious, what I'm doing now is since I back up the live sessions, I've actually backed these same folders up into my cloned location of the repo. Basically, this is like a magic portal where I can now use shell commands to magically send these documents up into the GitHub cloud. So I can get,
Yeah.
if I do git status, you'll see that I have these two new folders for 9.4 and 9.5. I can now add them, commit them, do my message. Hey, kiddo, we're almost done. Module 9, and then do a git push. And this git push is the magic command to basically upload to my personal repo. And now if I refresh my repository, you'll see in our live session those same folders and files with my comments and things here. So the reason why like hardcore developers prefer the command line version instead of the UI is because most of the time we're going to be editing these files in different file editors and we want to just command line them up into the cloud without having to manually drag and drop and upload things, right? Which can be a pain. This command line can also be fully automated as well. And you can also have actions that are listening for when things are pushed or committed to open up like code reviews and things like that. So there's lots of definitely more complicated things you can do with GitHub. But for the scope of this bootcamp, your goal is to do these notebooks and do the slide decks and fully synthesize the capstone, and then just have them publicly available, both for us to grade them as well as part of your public portfolio for others to review. Because you can also link your GitHub on your resume and stuff like that for people to see as like a public portfolio of your work. I say that like in art, right? And like photography, art, etc. You have like your portfolio of work of art to prove that you know how to do photography, and painting and stuff. GitHub is kind of the same thing for data scientists and developers. You want to show to the world that you're able to do coding projects, right? And GitHub is a way to facilitate that public portfolio. All right,
And
235.
that's where the README part is important because a potential employer they won't look any further probably than looking at the README.
Yeah. Yeah. If I go to one of mine, I do like a bunch of Databricks crap stuff in here somewhere. Like Databricks demos. You'll see I have like readmes for a lot of these demos, like some baseball thing that I did. Not, of course, I picked the only one that doesn't have it. Uh, yes, you do play baseball. I don't know. It's one of my rag. Oh, yeah, here we go. So this is like a demo, and I've added a whole README on like how to do it and how to run it and the purpose and links and references and stuff. So that's why we recommend having READMEs. So as people go to your GitHub to view and see information and projects, they're able to get a high level understanding of what it looks like. That's also why I recommend doing PDFs for the capstone because PDFs will render inside of GitHub and the browser versus Word documents which don't. So PDFs and Markdown files are the best for like text content that you want to talk about with your code. All right, I'm late for my next call, but George, thanks for sticking around so late. Karen, I appreciate all your help. Expect a couple updates in the forums with all this information around GitHub, the capstone deliverables, as well as working through these notebooks. Take your time with it. It's only 5 notebooks, but it'll take you a decent amount of time. And try and reference historical notebooks as you go from the last few weeks to make it clear like the logic and stuff that we expect.
Okay, thank you,
All
Alex.
right.
Can I get Karen for a quick question? Alex, I know you have to go, so thank you so much.
Of course. Yeah, go ahead. I
Well,
can probably stick around here.
Oh, okay. You mentioned slide decks. I might have missed something. Apart from the labs, what are the slide decks?
Yeah. So for module 10, I don't think it's open on, it may be open for the students, But if you go through the media sets for Module 10, you'll see that you're supposed to create a PowerPoint, which we
Ah,
actually give you as like a template. And your goal is to basically, now that you've done the work, you've done the EDA, done the data analysis, built the model, your goal is to synthesize it all up as a slide, as a PowerPoint, basically for executive stakeholders.
oh, okay.
Uh, and
Not
then I
fun.
would recommend,
Go ahead.
yeah, I
Go
would
ahead.
also recommend translating the PowerPoint into a like just a Word document, like a Google Doc or something that you can then save as a PDF. So then you
Yeah,
can have like a white paper essay version as
right.
well as your slide deck, and then submit both of those as your final part of the capstone.
Understood. Okay.
That's about it.
Okay, I will say that I don't have Microsoft, so I'll have to translate this to slide deck to see what it looks like. But yeah, again, that information will be all in the Module 10
Right.
media sets for next week. And again, all of this is due technically, I think, the 10th, but you'll probably have at least the week of the 5th, sometime in the week of the 15th,
Yeah.
lock and load it so we can get it all done. I think the 17th is the date they told me and Karen, but I think we at least have until the end of that week.
Super. Okay. Thank you.
Yes, sir.
And and that's it for me. Thank you very much, Alex and Karen,
Okay,
as always. And I will see you next week. And then the
great.
Yep.
forum
Yeah.
between. Okay. Thank you.
Thanks, George.
Bye.
And shortly, it looks like I should have the Moab Area Transit come and get me and take me to where I can finally get my electric trike back.